viewers, welcome back once more to Clever King Knowledge Quest. I am Kelvin Ikechukwu, the team lead. And today, we'll be looking at dimensional analysis. Remember, this is physics for early starters. So dimensional analysis is a subtopic under units and measurements. You can go back to my previous videos. We have done justice to units and measurements. Okay, so today we will be looking at an introduction. What is dimensional analysis? Its importance, and then its examples. All right, so without not wasting much time, let's dive in. What is dimensional analysis? Now, dimensional analysis is a powerful tool used by scientists and engineers to check out the relationship of all the physical quantities based on their dimensions, because the fundamental principles of physics deals with observations, and when there is observations, facts are always stated. So therefore, dimensional analysis helps us to calculate and check out the relationship between these fundamental units. Now, what is its importance? Its importance, I will be very fast, is that it helps us, or it gives more meaning to the physical quantities, especially the derived quantities. It helps us understand more of the concepts of physics. Now, when you say what is velocity, you will now know what makes up velocity. When you say what is force, you know what makes up force. It also helps us to check out errors in relationship of these quantities. Maybe when somebody stipulates a formula, you can be able to verify this formula and check if the dimensions like the dimension corresponds. If they do not correspond, then you know that there is an error. Like for instance, when somebody tells you that velocity is distance over time, you should be able to cross-check. When somebody tells you that acceleration is change in velocity over time, there should be something for you to cross-check. When they say that volume is meter cube, you should be able to cross-check. So these are the importance. This is why dimensional analysis came in. So in working out dimensional analysis, first of all, we use some capital letters to represent the key fundamental quantities. That is the physical quantities, which are the fundamental ones. So, and the key three fundamental quantities we have are mass, length, and time. So we use the letter, capital letter N, when we want to carry out a dimensional analysis work. We use the capital letter M to represent mass. We use capital letter L to represent length, and we use capital letter C to represent time. Remember that mass is what? The quantity of matter. So the units of mass are things like kilogram, gram, pounds. All these are units of mass. Now, length is what? The difference between what? A reference point. When we're talking about length, we can talk of things like distance, we can talk like things of like height, and their units are things like meter. We also have the centimeter, we have the millimeter, we have the kilometer. And time now is what? Measurements when an event is being occurred, and when an event occurs. And the units of time, you know, we have the seconds, we have the hours, we have the days, we have years, and so forth and so on. So we will make use of this. Dimensional analysis to generate most of our derived quantities. So join me as I do one now, fast. Now, when we have something like area, you know that area is simply length times breadth. Isn't also length times breadth. Now, length itself is meter. Remember, breadth also, which is like in distance, also is meter. So when we want to present these things, we put it in this form, L times L, which is L times L. Remember in the law of indices, when they have the same base, you pick one L and you sum up the power, which is L squared. So we can say that is why we say the area of length is meter squared. Now, another one, that for velocity. We know that velocity is what? Distance. Sorry, velocity is displacement. It is speed that is distance. Velocity is displacement over time. Now, displacement simply means distance covered in a straight line. So this also has to do with what? L. Now, what is time? Time is what? T. So it simply means that velocity is the same thing as L over T. And L stands for what? Meter, which is M. And T stands for what? Time, which is seconds. So that is why the SI unit of this is meter per second. It can also have other higher units. So this is just an introductory class. In the next class, we'll be looking deeply into how you can make use of this to cross-check if some equations are balanced or if some physical quantities and their relationship are not balanced. If you're yet to subscribe, please subscribe and join us. You have a lot to learn. Thank you and see you in the next class. Bye for now.